Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Ahmet Ceyhan, who holds a PhD in Nanoelectronics from Georgia Tech. How are you doing today?
I'm good, thank you. Thanks for the invitation, Rohan.
Yeah, thanks for coming on the podcast. So to get started, I wanted to ask what made you choose your major of electrical and electronics engineering for your bachelor's degree?
Yeah, so for bachelor's, I was always into math and physics. I thought at the time I had two options, either become a civil engineer at the time, or in electronics, I knew about electromagnetics a little bit, and I knew about Maxwell's equations, etc. And I really enjoyed those. I really wanted to dig deeper, and I found out that if I followed a path into electrical and electronics engineering, then I would be able to probably be happier, and that's why I picked it over the civil engineering. That's how it started, but it's mainly because of my love for math and physics back in high school. That's why I picked engineering.
Yeah, so what was your experience like while getting your degree?
Well, yeah, it turned out harder than I thought. Originally, like in high school, I went to a high school which was and I got my bachelor's degree in Turkey. The education system at the high school that I was at was a little bit more relaxed compared to other schools, and you have to prepare for um, an actual exam. Like and my in my year, I think about 1.5 million students were entering, and based on that, you choose the universities that you can go to. Some of them are better than the others, and it also pretty much determines which departments you can go to. The departments that most good students pick usually have higher points that you need to achieve. So when I was in high school and I was a pretty smart student. I was very hardworking, so I went ahead and graduated with a really good degree from my high school. But my high school was not as competitive as all the rest of them in terms of preparing you for this exam. So when I did good in that exam and then got into the university I was at, which I was, I think, the 250th among 1.5 million people as a result of that exam. I'm sorry. And then essentially I got the electrical engineering position in the one of the best technical schools in the country. Then I realized that the students that I was now learning with were completely different than those in my high school. So it was a bit of a cultural shock for me to get started there. Yeah, after a while, I started learning. So, for instance, things like being able to do everything in a way that you get the final result and the correct one in your first try versus showing your path, but not always getting to the best the final correct result was a big difference. I didn't know how to take exams. I used to just okay, I know the answer to this one. I go in and fix it. If I didn't know the full answer to something, I wouldn't even start the question. So those kind of things started. I started learning better from those and started learning to take the exams better and got used to it after a while. And I realized that I had to study a lot more. Electrical engineering, electronics wasn't that simple. It's everywhere in the world. It's a lot of homework based, and all these classes that you take, five of them at once, they're all heavy courses with a lot of homework. You really had to be on top of it. You couldn't let go even for a week, because then to catch up, you needed to let go of other classes, and then you would need to catch up on that. It just was a snowball effect. And I got used to being a little bit better with my time management, more organization, and kind of at the end of my first year, I had a lot of lessons learned beyond the lectures I took. Yeah.
Yeah. So what made you want to come over here and get a master's?
So the in my third year, I got into a little bit into the electronics part of things, the logic design, microarchitecture design, and I started enjoying very large scale integration, VLSI, and basically semiconductor physics. All those were the courses that I enjoyed the most. And there were people that I knew that had been in the United States, mainly in Purdue University. Purdue was really good at device engineering, and I used to talk to them and find out from them that what kind of things they're working on, and they all sounded really interesting to me. So I decided, okay, in the US, schools where the research is being done on the devices, the semiconductor devices, would be a good fit for me. So I started applying to schools that had good semiconductor device programs, and professors who were specialized in those areas. So that's how I decided to come in. I had some of my professors reach out to me in Turkey that used to do the semiconductor device research as well at in the university I was from. But I thought that okay, I want to go abroad and get some of these views because some of my friends were also recommending it that when you come here, then you're basically on your own. It's a little bit more like a you're free, like you're in a different country. There's a lot of things to explore, a lot of things to learn. It's not just your profession that you're going to learn here, not just science. You're not specifically a student anymore. You're actually working as an assistant somewhere. So it's a different life experience, and I wanted to take that on. And when I came here, I really enjoyed the environments that I was always in school and around with my friends. And I just decided to stay longer. Originally, I decided to come here and do some research and get a master's with a thesis, and then I would work a little bit and go back. That was my plan. Then I really enjoyed what I was doing, so I decided, okay, maybe a PhD in this field would be more fun, and I continued on top of that. And after that, I got my job, and I really loved my job. I still love it. So then it's been now about 10 years in the same job, and I still am working on it, and I really enjoy it every day. Now I don't want to go back. Like I really enjoy my job so much that it's like 50% of my life is my work, and I feel like if I go back now, I'm gonna restart on that front, and it's scary thought to me right now. So that's how I stayed.
Yeah.
Yeah.
Can you talk a bit about PhD research?
Yeah, so what we at the time that I was doing my PhD, one of the hottest topics was to look for alternate devices, semiconductor devices, compared to the complementary MOS logic that you have right now, which is charge-based. There were a bunch of research on different materials and architectures of developing those devices, as well as some different physical phenomena that you could use to create the devices for building your computation devices. So your computers and all that stuff. So like instead of charges moving one place through the other through above a barrier, and these might be a little bit too much detail, but there were a phenomena of tunneling of the electrons that you could use to build devices. At that time, various different materials and architectures were using to build those tunneling field effect transistors. Regular MOSFETs were getting created by new materials like graphene, carbon nanotube. And the interconnection between these devices were also being looked at for changing the copper technology to some a new material that could reduce the resistance or the capacitance as a total, the multiplication of the two, which determines the speed of communication. So I started looking into these various different materials, modeling them, and then creating models, using those models to implement actual implementation blocks that have a certain functionality, and calculate how the technology would be scaling from all these various different nanometers that you hear, like 22 nanometer, 12 nanometer, 10 nanometer, 7 nanometer, was trying to build the trends. That was my research of creating some, standard cell libraries and all of that, and implementing the blocks. And when I got my PhD on that topic, from all the way from the fundamentals of physics to model the devices and the interconnects to building an actual system out of it, I got a call from Intel, from people that I had met at some conferences that were in mostly in the process side, and they needed somebody to evaluate those process decisions to how they would impact the final block. And that became a power performance area estimation evaluation engineer. And I started at Intel that way, and I started developing the technology alongside those people who are really experts in the on the process side, trying to show them if they make certain process decisions, how they would impact the final, let's say, the CPU that you would be developing and sending to your customers. What kind of process changes would make it faster? What kind of process changes would be really costly in terms of the power that you spend, et cetera, et cetera. And making those decisions, it turned into something called the design technology co-optimization. So you're taking your designs and your technology decisions to build the process and co-optimizing the two, being aware of any upstream decisions, how they're going to impact you at the very end, which is what you send to your customers. And I still do that, and I still really enjoy that.
Yeah. So for
Yeah.
my last question, I wanted to ask if you have one piece of advice for someone who's still in high school or early in college wanting to follow a similar career path as you.
Yeah. So I would recommend nothing matters as much as being resilient. Just be resilient. Always get into the areas that you think that are outside of your comfort zone and keep learning. Even to this day, master's, PhD, 10 years of experience in this field. Every day after work, I start looking into things that I want to learn. For instance, things like hardware, software co-optimization, how are AI hardware different than the hardware that we have been building so far. I'm more on the upstream where I do the technology development and design technological optimization, but I go all the way downstream to try to understand how architectures could be changed to build different hardware. So that learning, that big picture understanding, it really helps you in your job in every piece of this. And just know you don't need to do everything, and you don't need to be an expert on every single thing. You just need to know who to work with whenever you have an idea. Ideas come from this exposure, and then whenever you have an idea, and it might not just pan out in the first try, second try, third try, just be resilient. At some point, even if that particular idea fails, you'll find out that you've learned a lot, and in your next idea, you're going to be using a lot of those learnings from that failure to improve your next step. So I would say being resilient and being on the learning path at all times, no matter what your age is, no matter what level you are at your work.
Yeah. All right,
Yeah.
then. Thank you for joining me on the podcast today.
Thank you, Rohan. Thanks for the invitation again.